Yeah. They're looking to reschedule it, but our scheduling for millions didn't match up very well. All right. So, note card. Uh-huh. So, there you go. All right. So these are sum and difference formulas. It's not overly complicated. Cosine of A plus B equals cosine of A cosine of B minus sine of A sine of B. And none of this will make sense until we actually do a few problems, but the second one, cosine of A minus B is the exact same thing except for the sign in between is opposite. Okay, when we have the sign involved, it's a little different. So the sine of A plus B is the sine of A cosine of B plus cosine of A sine of B. And the sine of A minus B is the sine of A cosine of B minus cosine of A sine of B. The tangent of A plus B is the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. And then the tangent of A minus B is the tangent of A minus the tangent of B over 1 plus tangent of A, tangent of B. All right, so that's all that goes on your note card for today. Okay, and we're just going to ease our way into this. So we're just going to deal with cosines today. Get out your unit circle, please. From your unit circle, what's the cosine of 60 degrees? One half. What's the cosine of 30 degrees? Square root of 3 over 2. And then what's a cosine of 15 degrees? It's probably like, what does it say on your unit circle? It's not there. Oh no. How could we find the cosine of 15 degrees if it's not there? Well, we can use a sum and difference formula. Okay. Now, what's the cosine of 45 degrees? Square root of 2 over 2. Any combinations of these make 15? Any combinations of the ones that we know the answers for? Cosine of 15 equals the cosine of 45 minus 30. Well, from your note card that we just wrote down, the cosine of 45 minus 30 would be the cosine of 45 cosine of 30 plus sine of 45 sine of 30. And you're going, what you talking about, Mr. Bierschbach? Well, this is A, this is B. We have the cosine of A minus B. It's the cosine of A, cosine of B, plus sine of A, sine of B. Once you get that written out, then you just put in the numbers for it. What's cosine of 45? Square root of 2 over 2. What's cosine of 30? Square root of 3 over 2. Okay, these aren't written up above, but they're on your unit circle. What's the sine of 45? Square root of 2 over 2. What's the sine of 30? 1/2. So then you do the math. You get the square root of 6 over 4 plus the square root of 2 over 4. Because when you multiply the numerators and you multiply the denominators. When you add, you got to count with their common denominator, you leave the denominator alone. So it's the square root of 6 plus the square root of 2 all over 4. We're done. So that's our end goal today, to be able to do this. Okay? But we got to take steps in getting there. How do we take steps in getting there? Well, because we're going to be dealing with like pi over 12, you got to know how to get to pi over 12. Yes, Ethan Brown.
You can't combine square root of 6 and square root of 2?
No. They're not like terms. It's like combining an x and a y. You can't combine an x and a y. That's like breeding a mouse with an elephant. It just doesn't work.
I just say that to my
All right. So, pi over 12. How do we get pi over 12? Well, what over 12 minus what over 12? Well, could we take like, 10 pi over 12 minus 9 pi over 12 equals pi over 12, right? But are 10 pi over 12 and 9 pi over 12 on your unit circle? They are. They're just not in that form. What's 10 pi over 12? 5 pi over 6. What's 9 pi over 12? 3 pi over 4. Are those both on your unit circle? Then that works. Okay. Could you take 2 pi over 12 minus 1 pi over 12 to get pi over 12? Well, this equals pi over 12, and 2 pi over 12 is pi over 6. But is this on your unit circle? Since that's not on your unit circle, we can't put numbers in its place. We've got to put numbers from our unit circle in its place. See how we did that? These are numbers from the unit circle. We got to put numbers from the unit circle in its place. So when you're dealing with this today, and we're dealing with radians, you got to use numbers from your unit circle. So you got to be able to think, okay, would this be on the unit circle? Yes, it is. Would this be on the unit circle? No, it's not. Okay. So it's like 5 pi over 12 minus 4 pi over 12. Now, 4 pi over 12 is on the unit circle. It's pi over 3. This is not on the unit circle, so it does not work to make pi over 12. So you'll have to be careful there, okay? So if we wanted to find, like, 13 pi over 12, what two numbers would we add up to make 13 pi over 12 that are on the unit circle? Well, what I do is I always put them over 12. Now, what are two numbers that add up to be 13? Well, 1 and 12 add up to be 13, but is pi over 12 on the unit circle? No, so we can't use 1 and 12. How about 2 and 11? 2 pi over 12 is pi over 6. That works. But is 11 pi over 12 in the unit circle? No. So 2 and 11 don't work. How about 3 and 10? 3 pi over 10 is pi over 4. 10 pi over 12 is 5 pi over 6. So it's pi over 4 plus 5 pi over 6. So you're going to have to be able to figure out ones like this where what goes into it that is on the unit circle? Well, these two go into it, which makes these two, which are both on the unit circle. Okay, so that's the thinking part of today. Okay, that's the part where you have to think today. Now, they will have some problems that are all done up for you, like what's pi over 4 minus pi over 3? And you'll have to figure that out. Well, if you're told to find pi over 4 minus pi over 3, you get a common denominator. What's our common denominator? 12. Pi over 4 is how many pi over 12? 3 pi over 12. Pi over 3 is how many pi over 12? 4 pi over 12. 3 minus 4 is negative 1 pi over 12. Bada, bing, bada, boom. Okay? Let's do one more of those. What's the common denominator for these two? Pi over 4 plus pi over 6. 12 again. So pi over 4 is 3 pi over 12. Plus pi over 6 is 2 pi over 12. You get 5 pi over 12. Okay, so you can add fractions, right? All right. So we'll have to figure out numbers that go into other numbers. And then let's just work with degrees here for a second. What two numbers make 105 degrees? What two numbers from your unit? Because there's 105 degrees on your unit circle. No. What two numbers from your unit circle make 105 degrees? So you'd use 60 plus 45. Okay. What two numbers would make negative 15 degrees? Negative 15 degrees. What two numbers from a unit circle would make negative 15? What? 30 minus 45 degrees. Okay. So what two numbers would make 5 pi over 12? 3 pi over 12 plus 2 pi over 12. which would be pi over 4 plus pi over 6. Matthew, you are on today. Okay? So, you'll be doing problems like this, and then we'll finally get to the problems where we just find like the cosine of 15 degrees. So what two numbers did we subtract to make, oh, did we already do cosine of 15 degrees in an example up here somewhere? Yeah, we did. How about 105 then?
I simply cannot remember if we did that already.
Cosine of 105. So what two numbers did we say made 105? So then once they ask this, then they want you to do the problem all the way out. So this is the cosine of 60, cosine of 45, and then minus sine of 60, sine of 45. What's the cosine of 60? 1/2. Cosine of 45. Square root 2 over 2. Sine of 60. Square root 3 over 2. Sine of 45. Square root 2 over 2. So all of your answers will look very similar to each other. They'll all have a square root of 2 and a square root of 6 and a 4 in the denominator. It'll just be different combinations of pluses and minuses. So the cosine of 105 degrees is square root of 2 minus square root of 6 all over 4. Let's do another one. The cosine of 17 pi over 12. What two numbers add up to be 17 pi over 12 that are on a unit circle? This is where I always put them over 12 first, and then I'll make them into the reduced one. 11 pi over 6 is 22 pi over 12 minus 22 minus what is 17? 22 minus 5. No, let's not go there. That won't work. Let's add two numbers to make 17. You can't use 1 and 16. Can you use 2 and 15? 8 and 9 work. You could use 2 and 15, but let's use 8 and 9 since you guys want to go there. Okay? So this is the cosine. 8 over 12 is 2 pi over 3. 9 over 12 is 3 pi over 4. Okay? So it's the cosine of 2 pi over 3, cosine of 3 pi over 4, minus sine of 2 pi over 3, sine of 3 pi over 4. What's the cosine of 2 pi over 3? Negative 1/2. What's the cosine of 3 pi over 4? Negative square root of 2 over 2. Minus the sine of 2 pi over 3. Square root of 3 over 2. Sine of 3 pi over 4. So you get positive, because the negative times the negative is positive, square root of 2 over 4 minus square root of 6 over 4, which equals square root of 2 minus square root of 6 all over 4. Your assignment is 3 through 25, the odds, on page 179.